Did I turn myself off? Acetic acid is based on the acetate ion. Remember, there's an ATE ending, change it to ic acid. So acetic acid would be HC2H3O2. And again, this is the acidic hydrogen ionizable, or ionic hydrogen, right there. And this is your anion. Go to the hydrogen, and everything behind that first hydrogen is a polyion in the structure of that acid. And so this would break up in water to H plus C2H3O2 minus. So that's one way to write it. Sometimes you'll have some shorthand methods where the acetate ion is written in an abbreviated form, HOAC. And so that is written, and you'll see them in the literature like this, and that will, but you will always have that ionizable hydrogen still out in front of the abbreviation, and that will give you an H plus OAC minus. Now, there are, when you get to organic chemistry, you'll see it in a structural way. Here's your acetate ion, and here's your ionizable hydrogen, and that's what will break off, and there's your acetate ion right there. And you'll also see it written H3CCOOH like that, and it'll break off the end. So I'm just showing you some formats that are used in the literature, so you at least maybe it'll strike a nerve when you have to need it. For the most part, we're going to use that, and you'll be able to tell who's the weak acid. Now, having said everything I've said, now how do you write metathesis reactions that include acid bases, weak acids and weak bases as driving forces? Well, here's one that will do that. This is a weak acid reacting with a base. You treat it in the same format that you did in the salt-salt interactions, except when you write the ionic equations and the net ionic equations, you, listen, do not show the weak electrolytes in ionic form. And that's the point of this note. So first, we will write the product. It's the AX-BY exchange, and so that would be a sodium acetate, because that's a plus and sodium's a minus. So sum of charges equals 0, so that's the correct formula. And then you have H hooking up with the water. Now in this equation, this is a salt, and this is a weak acid, and is the driving force. We learned it's not a member of the six. But this also is a weak acid. Over here, and this is a strong base. It should be shown 100% ionized. So when you write the ionic equation, do not show the weak acids in ionic form, but the salt, all salts are ionic compounds and ionize 100%. So you show this ionized, and you show the strong electrolytes ionized. Salts, all salts are shown in ionic form, and strong electrolytes in ionic form. So when this is written, it's HC2H3O2 aqueous plus sodium plus the OH. I'll leave all the states out. It's all in water. And this is sodium plus C2H3O2 minus plus the driving force. Notice how I did not write the weak electrolytes, the water and the acetic acid in ionic form, but the sodium hydroxide and the salt I wrote in ionic form. And the net ionic equation, this only has one spectator ion in this type of reaction, so it's HC2H3O2 plus hydroxide goes to C2H3O2 plus H2O. And so there's your net. And notice again, the weak electrolytes are shown as molecular forms. At the bottom of the handout on the driving force of metathesis, there's some reactions, and these little gas products over here in this left column are your gas decomp products, and those are acceptable in the scientific community as the gas decomp driving forces of a reaction. But you need to know how to deal with those when writing a metathesis. For example, if you had a reaction between calcium carbonate and HCl, for example, the outcome of this would be exchange, just like we've been teaching, AXBY goes to AYBX thing, and you would have H2CO3 on the end. This is carbonic acid. If you see this carbonic acid, H2CO3, you have one more step to go, because under normal conditions, carbonic acid will break down into CO2 and water. Many of you have taken vinegar and baking soda and mixed them together. Well, the bubbling is the CO2 coming out of that. And then you've seen H2O and water formed right there. Well, this is what essentially in equation form. So when you write this, you have one more step. You want to include that H2O and CO2 at the end. And I'll just tag that with a gas. And this is your gas decomp driving force. So there, you need to get comfortable with, well, when you solve a metathesis reaction and out comes carbonic acid, you know you have to write in the products of that decomposition. Well, that's not the only one in the collection. If you come out with nitrous acid, you have these gas phase components as driving forces. If you come out with sulfurous acid, you have these components. So this is, you'll be in front of you, but at least you check. Now H2S is a driving force in itself. It's not a decomp product, but well, it's got a reaction over here that shows H2S form, and that will leave the system. The common denominator in all of the driving forces is that it essentially leaves the system as a precipitant, or as it goes into a bonded mode in the acids, or it leaves the system as a gas. And here's, of course, ammonium. If the ammonium hydroxide is formed due to the exchange, then you have to break it and show it as an ammonia, and that will come out as a gas along with water. So those are the only ones you'll have to worry with for test purposes, but I want you to understand that when you do solve a metathesis and these compounds show up, you have to go one more step to get the appropriate reaction form. Okay? Well, that takes us through all of the classes of reaction.